Everybody, today I'll explain to you guys how to do some simple acid plus base reactions. Acid plus base reactions are usually called neutralization reactions. We'll start with HCl plus NaOH. Now, a simple hack that I've learned to predict the reactions to an acid, which is usually something with a hydrogen ion in front of it, and a base, which is something usually containing a hydroxide ion, is to take this apart into smaller bits so that we can digest it a little bit easier. Here, I'll show you guys what I mean. So HCl is obviously just a combination of H plus hydrogen and Cl minus. Remember that we're using the charges from the periodic table. And NaOH is just Na plus and OH minus. Usually in a neutralization reaction between an acid and a base, we will get the products water and salt. Water in its chemical formula is H2O, and salt usually in this reaction is whatever remains. Water, H2O, is also HOH. Keep that in mind. Here we can see that we have an H plus and an OH minus. Let's write that down. H plus with an OH minus. That, when we crisscross our charges, will make HOH. Now we found water, H2O. Now, as we can see, we have the Na and the Cl remaining. We do the same thing with them, Na plus, Cl minus, and we crisscross our charges to get NaCl. Our salt. Really easy, right? Let's try a different one. We'll do We'll do H2SO4 plus NaOH. As we can see, this is our acid from the H, and this is our base from the OH. Using the hack, let's split the H2SO4 up. H2SO4 is just the H plus combined with the SO4 2 minus polyatomic ion. NaOH is just Na plus and OH minus combined. You can tell that when these would crisscross, they would combine to make this, and when these crisscross, they would combine to make this. Now, as we know, an acid plus a base reaction usually results, or they always do, result in a water and a salt molecule. Now, water is H2O or HOH. Right, I should just do a slash because brackets in chemistry mean something different. Okay. We have an H plus here and an OH minus here. Those we know combined when we crisscross their charges to create an HOH, also known as an H2O. And what remains is our SO4 2 minus and our Na plus to create SO4 Na2 when we crisscross our charges. Usually in chemistry, we like to write the positive metal first and then the negative. But I'm just going to leave it as this right now. With this, you might think you're done. However, we now have to balance the equation as it's unbalanced. You can tell it's unbalanced because here you only have one Na, one sodium, and here you have 2. How to balance equations? That's really easy. Start by counting how many of each element you have. We have Nas, we have H's, we have O's, and when dealing with polyatomic ions and balancing, it's usually easier to balance them as a group because they're polyatomic, right? They're already a group. So balance them as they are. And then SO4. Left, right. Left, right, LR is for, this is the left side of our equation. If I was to write it down in a line, this would be on the left side of the arrow, and this would be on the right side of the arrow. On the left side of the arrow, we have 1 Na. We have these 2 hydrogens plus this hydrogen. So 2 plus 1, 3 hydrogens. We have only 1 oxygen. And you might say, well, we have these 4 over here, but no, that's part of the polyatomic SO4, right? So other than that SO4, we only have 1 oxygen. And we only have 1 SO4 here. Here we have 2 hydrogens, 2 NAs, 1 SO4, and 1 oxygen. You can see that the O's and the SO4s are already balanced. There's 1 of them on each side, but the hydrogens and the NAs are unbalanced. To balance, we obviously need 2 on the first side, right? So we have 2 NAs. Let's put a 2 in front. I'll do this in red. Now we have 2 NAs, and also now we have to update. We have 2 oxygens, and we have 2 plus these 2 hydrogens. So we have 4 hydrogens. Now we have our NAs balanced, and we still have our SO4s balanced. Now what's left is the O's and the H's to balance, which is really easy. Obviously, we should balance it on this side of the equation, right? The right side of the, I keep calling them an equation, reaction. I'm really used to math. In order to get 4 hydrogens and 2 oxygens on this side of the reaction, we need to put a 2 there, because that means that we'll now have 4 hydrogens. There's no more hydrogens in this side of the reaction, and 2 oxygens. Now, as you can see, 2, 2, 4, 4, 2, 2, 1, 1. It's balanced. I hope this helped you a lot, this video. And in this little tiny space, I'm going to, here, I'll even move it forward so it's not as tiny. I'm going to quickly write some notes for you. 1. With an acid, oops, it's a little bit blurry. We'll have it back here. Okay, with an acid plus a base reaction, acid is an H plus, and base is an O minus, usually for an acid, right? You will get, or result, a salt plus water molecule. Okay, first piece of notes. Secondly, when it comes to balancing, remember to, just to make it easier on yourself, balance the polyatomic ions as a whole. And remember to have both sides have the same amount of elements. Okay, thank you so much for watching. I hope this video helped you, and if it did, be sure to comment or like the video. Thank you.